Hey everyone, welcome back. It's been a while, I know. It's been super busy with everything going on, school and everything, but I'm glad to be back making videos for math and let's begin. So we're tackling a math diploma this time. This is like I'm pretty sure this is a practice test 2 off of Quest A Plus. So if you want to follow along, just feel free. I just wanted to, provide some perspective into like how you would kind of think when you're doing some of these questions, and hopefully you find it helpful. So yeah, like, with that being said, let's dive straight into it. I mean, you can read this whole thing, but I what I do is I like to skip to the information. So this question says that, or the source says we have a diameter of 2.5 meters and an arc length between A and B, which are labeled here, being 87 centimeters. Now, our radius, meaning our distance all the way across the circle, is going to be 2.5 meters, not centimeters. Notice how the units are going to be different. And just remember that radius is just diameter divided by 2. So 2.5 divided by 2 is just 1.25. Now you can just toss this into your arc length formula, which is theta equals A over R, where our arc length is 87 centimeters. But remember, we want to have the same units here. You can't use centimeters with meters. That's crossing units. It doesn't work like that. So you have to convert one to the other. So what I'm going to do is I'm going to say 87 centimeters. And we're going to use dimensional analysis here. So in 1 meter, which is what we want, we put that on top on the numerator. We're going to divide what we don't want. So we don't want centimeters. And there's 100 centimeters in 1 meter. So if you do this, 87 divided by 100, you're going to get 0.87, which is going to be your arc length. So I'm going to say theta is equal to our arc length, which is 0.87 over 1.25. Sorry, 1.25. You're going to get your angle equal to 0.696. And remember that this is in radians, not degrees. When you're using your arc length formula, you're going to get your answer in radians. So what we have to do here is to convert radians to degrees. Since our answer is asking for degrees, we're gonna divide by pi. So divide by pi, because we don't want radians, and we're going to put what we want on the top, which is degrees. So there's in 1 radian, or 1 pi radian, there's 180 degrees. So that's why we do this. And these units will cancel out. And your answer here should be times 180 divided by pi. And this amounts to 39.87, which will round up to the nearest degree to 40 degrees. So our answer here should be C, 40 degrees. So the way we do this question here is we have 2 points, A and B, which are on the unit circle. So on the unit circle, what that tells us is our radius is going to be equal to 1. And we can find some key trigonometric ratios based off of that. So I want to draw this out here. Our first point is positive 1/2, comma, root 3 over 2. So that's going to be in the first quadrant because both the x and y are positive. So we're going to have root 3 over 2 as our y, and 1/2 as our x. And this is going to be point B. Now we're looking at point A. It's going to be in quadrant 3 because you have negative x, negative y, and the only place you can both have negative x and negative y is in this quadrant right here. So I'll just label these points correspondingly. So we'll have root 2, negative square root 2 over 2, square root 2 over 2. And this will be point A. Now point C, they say, lies on 0, 0 on the unit circle. So this point here. And we're looking for the angle of ACB. So effectively, we're looking for this angle right here. So how do we find this angle? First of all, I would like to say that remember our coordinates, x and y. That's just equal to cos theta, comma, sine theta on the unit circle. So that's a key thing to remember. And if we say that cos theta is equal to negative root 2 over 2, you should remember from your unit circle that we only have theta equal to root 2 over 2 when we have a reference angle, pi over 4, or 45 degrees. In this case, we're asked for radians, so we're going to keep it in radians. So pi over 4 in this case is our reference angle. For this point, root 2 over 2, comma, root 2 over 2. So we're going to have a reference angle here. Our reference angle equals pi over 4. And if this point's 180, which is 180 right here, this point is going to be equal to pi radians. And remember, a whole rotation is 2 pi radians. The way we find our angle in standard position, it's going to be, well, pi is just 1 pi over 1, right? So we could say that we can make it the same fraction and say it's 4 pi over 4 plus this pi over 4 here, which gives us a fraction of 5 pi fourths to find this first angle in standard position here. Now, in terms of the second one, you're just doing the same thing. You have sine theta equals, what is it, root 3 over 2. And you'll notice that theta is equal to, or sine theta is equal to root 3 over 2 when you have a reference angle of pi over 3, or 60 degrees. So since our angle is in the first quadrant, our reference angle is equal to our standard angle. So we're just going to have pi over 3 here. Now, so to find this angle, all I really want to do is just get this angle here, which is A. So, sorry, this is getting a bit messy, but so I would say you would get this angle A from here to here. And if you subtract this area here, that would be the same as this from here to here. So what we can do is just our final angle minus our initial angle. So our final angle is 5 pi fourths. And we're going to subtract pi over 3. And if you do this in your calculator, you're going to get 2.87 dot dot dot. But it'll round up to 2.88, which is what we're asked to do. So rounding to the nearest hundredth here. Now on this next question, again, we have to look very carefully here because when something's on the unit circle, that's key information, right? Because otherwise, it's just kind of hard. But we have this point x and y, but we know that our radius or our hypotenuse is going to be 1 since it's on the unit circle. So we're asked for the exact value of cotangent theta. So remember that cotangent theta is just equal to x over y. So in this case, we have to find our value of x. So using Pythagorean theorem, we have, remember, I'll just draw this triangle out, because since it's on the unit circle, I'll draw this point out on the unit circle. And notice that we have a negative y and a positive x. So it can't be in this quadrant, because then we would have a negative x and a negative y. It can't be in this quadrant either, because we would have a positive y. Can't be in this quadrant because we would have both a positive y and a positive x. So it has to be in quadrant 4. This angle has to terminate in quadrant 4 because we have, in this quadrant, we have a positive x and a negative y. So just drawing this out, our radius is 1 and our y is negative 18 over 7 because it's on the unit circle. Remember, radius 1. And now all you do is Pythagorean theorem. So I'm going to get 1 squared minus negative 8 over 17 squared is equal to x squared. If you rearrange for the Pythagorean theorem, now I'm just going to square root this. And you're going to get 1 squared minus negative 8 over 17 squared is equal to x. So let's put this in our calculator here. So 1 squared minus negative 8 over 17 squared. And we're taking the square root of this here. And what you're going to get as x if you convert it into a fraction is 15 over 17. So now, all we have to do is plug it back into our formula. So cotangent x, or cotangent theta is equal to x over y. So we have 15 over 17 all over negative 8 over 17. I'm going to rewrite it like this. You're going to get 15 over 17 divided by negative 8 over 17. And remember, when you divide, it's the same as multiplying by the reciprocal. So 15 over 17 times negative 17 over 8. And now you can do this in your calculator. So 15 times 17 is going to become your numerator. You're going to get 255 over 17 times 8, 136. So now we can see if this fraction can be simplified any further. And this should simplify down to negative 15 over 8. And if we look at our option choices here, 15 over 8 is going to be D. So now we have this question here. Cosecant of 4 pi over 3 plus k is equal to cotangent of 8 pi over 3. So first of all, I would rewrite all of this. So cosecant is the same thing as saying 1 over sine theta is equal to cosecant theta. So what is theta in this case? It's 4 pi over 3. So we're going to say 1 over sine of 4 pi thirds plus an unknown value k is equal to cotangent of 8 pi over 3. Now I want to rewrite cotangent as 1 over tan theta is equal to cot theta. And you'll realize that this just becomes 1 over tan of 8 pi thirds. 8 pi thirds, okay? So I want to find the exact value for sine of 4 pi over 3. Since we're asked to find all the exact values here. And I also want to find the exact value of tan of 8 pi over 3. Because these will be very useful here. So if we have sine of 4 pi thirds, our reference angle here is going to be pi over 3. And if we think about this with respects to the unit circle, this would be 3 pi thirds. So 4 pi thirds would be located somewhere down here. And just notice that our y is going to be negative, since sine theta is equal to y, right? So whatever sine of 4 pi thirds is, it's going to be negative. And if you have a reference angle of pi over 3, think back to your unit circle, the exact value of sine at pi over 3 is just root 3 over 2. So I'm going to plug this in back into my equation. So root 3 over negative 2 plus k is equal to cotangent, or 1 over tan 8 pi 3. So now, finding tan of 8 pi 3. How do we do this? So there's only a couple places where tan can be positive. So you have this using the cast rule. So it could be positive either here, in the first quadrant, or in the third quadrant. So you're going to have two answers here, but 8 pi thirds. So just think about this with respect to the unit circle. This would be 3 pi thirds. This would be 6 pi thirds. We go make a full revolution. So if this is 6 pi thirds, then we'd be our angle would be located here, because it'd be 2 pi thirds over our actual anticipated angle. So finding the exact value of tan of 8 pi 3, what we're going to do is we're going to draw this out here. And we're just going to try to find where this angle is located, right? So we have 3 pi 3 on the 180. And then we would have 6 pi 3 on the 180. And now you have an additional 2 pi 3, which would be right just before this 3 pi 3. So our angle would look something like this. It would go around once. Sorry. It would go around once and hit this point here, which would be 8 pi over 3. Now, we can use our cast rule. So CAST. And we'd see that our tan ratio of 8 pi thirds is actually going to be negative because only sine is positive in this quadrant. And also notice that our reference angle is pi over 3. So how do we find the exact value here? So remember that tan is mathematically equivalent to cos theta or sine theta over cos theta. So we know sine at pi over 3 is going to be root 3 over 2. And you're going to divide that sometimes by the reciprocal of cos at pi over 3. Cos of pi over 3 is just going to be 1 over 2. So if we're dividing by 1 over 2, that's the same thing as multiplying by 2. Notice how these cancel out, and you're going to get tan of 8 pi over 3 is equal to negative root 3. Now, if you're unsure of like the exact values and finding this, again, just put it in your calculator and make sure it's in radians if you're using radians. So in this case, I'm going to go in my calculator, type in tan of 8 pi over 3, and then you're going to type in negative square root of 3. And notice how those values are going to be equal. So that's how you know you've done this right. And now what you're going to get is this equation here. So I would replace tan of 8 pi over 3 with just this beautiful negative root 3 here. Now we just have to find k. So the way we find k is I just subtract this 1 over, we subtract this 1 over root 3 over 2. So you get, yeah, and just make sure you're keeping this in brackets. So you have 1 over root 3 minus negative 2 over root 3 once you flip this fraction. Because, again, 1 divided by square root 3 over 2 is just the same as multiplying by 2 over root 3, right? Multiplying by reciprocal. So this would be the same when you're subtracting by a negative. This becomes the same as just adding. So you have negative 1 over root 3 plus 2 over root 3, which just becomes the positive 1 over root 3. So 1 over root 3 being positive should be our answer. No. We're looking for parameters b and c on this based off this graph. So b is going to be our 2 pi over r period. That's going to be formula for b, which is the horizontal stretch. And if we're looking for c, that's going to be the phase shift. So c is our phase shift. Now, the way you actually find this is you're going to look. So if we have a cos graph and a is greater than 0, meaning there's no reflection in the y-axis, or in the x-axis, sorry, your y equals cos x is going to look like this. So it's gonna be the first maximum above the midline. So the first maximum at the midline. That's going to be our c value. So we can see that this is translated to the right, right? So we have a horizontal translation because our original graph would start where the midline meets the y-axis, and that would be the first maximum there. However, in this one, that's not the case. So we have to look for this distance here. But first, I'd probably begin by finding this b value. So 2 pi over our period. So our period, again, is just going to be every time our graph repeats. So I'd say first, our midline looks to be at about 3. So we're going to go from max to min to max. and that's going to be our period. So from here, here to here, that's our period. You could also say from this point here, down to here, down to here, could also be our period. So that's what I'm going to use. So we're saying our period is 4 pi. So if we plug that into our formula, we have 2 pi over our period, which is 4 pi. These pi's cancel out, and you get 2 over 4, which is just 1/2. So 1/2 is the correct b value. So we're already having a good start here. Now we just have to find the value from here to here, because this will be our positive phase shift. So again, this looks to be 4 pi right here, and we're looking for this point on x. So I guess in what increments could you increase by 4 times to get to 4 pi? So I could say this is like pi, this is 2 pi, this is 3 pi, this is 4 pi. So I think we're increasing by increments of pi. So based off that logic, it's not going to be pi over 2, because that doesn't work in terms of this x scale. So our answer should be A. Now this one's a bit tricky. We have the graphs of y equals log base 3 of x and tan of x on the right. And we have the point A, comma, negative 1/2 marked on the graph of log of x. So this is y equals log 3 of x. And this one is just y equals tangent of x. We're looking for a point k, comma, a marked on the graph of tan of x. So we're looking for this specific point right here. So all we got to find is these a values, this a value first. So our a value here on our log graph is going to be equivalent to the a value on our tan graph. So I'd begin by finding this log graph value of a. So again, we have the point comma, or we have the point a comma 1/2 or negative 1/2. And basically what we're going to do is we're going to think about this as x and y. So based off our equation, we can plug this in here. So we get y is equal to negative 1/2, which is equal to log 3 of a. And if you rearrange this logarithm here, you're going to get 3 to the negative 1/2 is equal to a. So basically 1 over square root 3 is equal to a. And now we got to find the value of k. So we found our x coordinate here, which is tan y equals tan x. And in this case, our x value is going to be k, right? So I would say our coordinate is k, comma, a. And we found that a is 1 over root 3. So we can use this information. Again, we're just going to plug this into our equation. So y is equal to 1 over root 3. Let's plug that in. Tan of x just becomes tan of k. And now all you have to do to find k is you just take tan inverse. So tan inverse of 1 over root 3, which will be equal to k. And make sure you're doing this in degree mode, since our answer is asking for degrees. So in this case, I'll switch my calculator to degree mode, and I'll take the tan inverse of 1 over square root of 3. And that'll give us 30 degrees here. And remember that this is only going to be our reference angle. It's 30 degrees. So we could have a couple possible angles if we think about this. But again, our coordinate point is going to be k, comma, 1 over root 3. So remember that tan is only positive in, using the cast rule, it's only positive in the first quadrant and the third quadrant. So the only possible angles here would either be 30 degrees or this angle down here, which is 180 plus this reference angle of 30, which is 210 degrees. So based off of that, our only possible answer here is going to be 210, which is C. So now, this sine equation, I think we're moving on to Trig 2 now. So this is going to be the Trig 2 section. this equation here is a bit tricky. All our values are just going to be, a is going to be positive, b is going to be greater than 0. So if b is greater than, yeah, so this is just ensuring that we have no negative answers. You'll see what I mean later. And honestly, what I think we'll do here is, since each factor, we can set each factor to 0. So let's say sine of 2x minus 2 is equal to 0. You'll rearrange and you'll get sine of x is equal to 1. And then this one, you'll get sine of x is equal to negative b over a. Now, this really helps to draw it out because our domain is 0 to 2 pi. So we have 0 all the way to 2 pi way back around. And I just want to think about this. So sine x is equal to 1 in one position because y is equal to sine x, remember? And sine of x, or aka y, is only equal to 1 when our angle is going to be pi over 2, or coterminal with pi over 2. In this case, our domain only calls for 2 pi, and our domain cannot equal 2 pi neither. So this yields us one solution. So this question, or this equation, this first equation here, yields us one solution. So we're looking for the number of solutions. This one's only one solution in this domain. Now, the second one, we have negative b over a. You're probably wondering, how do I even use this? This is not useful information. However, remember, we have to use our cast rule. So sine is y, right? Y can only be negative down in these two quadrants. You could say this is a negative, or sorry, this is b, this is negative a, and this is negative a, this is b. Those are two possible combinations of what this graph could look like. And it's going to be less than 2 pi for sure, so it meets the domain, meaning this will only yield us two solutions. If we have one solution on the other one and two on this one, then we have 3 total solutions. Now this question here, all we're going to do is we're going to isolate for cos theta. So we're going to get cos squared theta is equal to 5 over 10. Cos squared theta is equal to 1 over 2. And now we just square root it. Cos theta is equal to the plus or minus, so don't forget the plus or minus, 1 over square root of 2. If we rationalize this, it becomes cos theta is equal to plus minus square root 2 over 2. And based off our unit circle knowledge, we should be able to do this in a snap. So I just drew out all these angles here. So since we can be in all quadrants, there's a couple of solutions that are possible here. And remember that our reference angle, when we have pi over 2, or 2 pi over, when we have root 2 over 2, cos theta is equal to root 2 over 2, our reference angle is going to be pi over 4. So this first angle is going to be pi over 4. The second one is going to be, remember this is 4 pi fourths. Therefore this one would be 3 pi fourths. This one's 1 plus 4 pi over 4, which is 5 pi fourths. And then this one all the way down here is just 8 pi fourths minus 1 pi fourth. This becomes 7 pi fourths. We're asked for the general solution, right? So we have to find two possible general solutions here that'll work. So the first one I see is we have this angle to this angle. They are exactly across from each other. So they're diagonally across from each other. And basically this distance from here to here is half the circle, if you think about it. This would be the other half of the circle, other half of the circle. So the way you go from 3 pi fourths to 7 pi fourths is just you add pi. So I would say 3 pi over 4 plus pi n is one of our possible solutions. Now if we move all the way over here, we could have the other solution, right? So we could have the other half of this, which is pi over 4. Then you're moving half the circle to go here, half the circle to go here. So I'd say pi over 4 plus pi n, where n is an element of the integers. So do we have anything that looks like that? Pi over 4 plus pi n, do pi over 4 plus pi n. So any solution that doesn't have Jane, I can just automatically scribble out. Now we're looking between Sandy's solution or Noah's solution. So Sandy's solution doesn't work because this is only one part of our expression. Sandy's solution is automatically wrong, and that would mean by process of elimination our answer should be D, but we do want to check it, right? So they're saying pi over 4 plus multiples of pi over 2 will yield us our solution. So if we think about this, we can try this out. So if we add pi over 4, then we add this distance here, pi over 2. I mean, you can just try it in your calculator, honestly. Like, I would just say 1 over 4 plus 1 over 2. Sorry, 1 over 2, because just ignore the pi for now. 1/4 plus that. You're getting 3 pi fourths. And then, again, I would just add another pi over 2, which will give you 5 pi fourths. And then you add another 1 over 2, which will give you 7 pi fourths. So this solution, this general solution, is going to work for this equation. So even by process of elimination, if you check it, you'll see that this distance actually between here is pi over 2. So this works. So our answer here is going to be D. So we have an incorrectly simplified solution here, and we have to look at the step which they mess up. So this is a trig identity. So again, first thing I'd rewrite our first part of our fraction here. So I'd say 2. Remember that cotangent is cos over sine. So cos theta over sine theta all over cosecant squared x is just going to be 1 over sine squared. That's our first fraction. That's the top half, which I'm going to simplify in one step. That's just this part. So we have 2 cos theta sine theta times sine squared theta over 1. Because remember that dividing, remember this would look like cos theta sine theta divided by 1 over sine squared theta. That'd be the same thing as multiplying by the reciprocal. So all I'm going to do is I'm going to multiply by the reciprocal. So you're going to get 2 cos theta sine squared theta over sine. What they do is they're going to simplify this out, which is true. So you'll get 2 cos theta sine theta on the numerator of your fraction. What they did is they multiplied by 1 over our denominator. So times 1 over cos squared x sine squared. Sorry if I'm using theta instead of x. It really for this shouldn't matter too much. But remember that dividing is the same as multiplying. So these expressions are going to be mathematically equivalent. So I should probably write this as all over cos squared x sine squared x. Now, from here, what you can do is honestly cos squared x plus sine squared x. If you look at this, that identity is just equal to 1. So this whole part, so remember cos squared x plus sine squared, that's equal to 1, because this would be x squared plus y squared. This is the Pythagorean identity, right? So this fraction becomes 1 over 1. What they did is they expanded it, and I'm not sure where this sine squared x came, or sorry, I'm not sure how they expanded it into this when it should be equivalent to 1. So therefore, our first mistake is going to be located on step 2. Now, I think, guys, that'll be it for this video. I hope it helped. It's been a while, so again, just if I'm rusty or anything, it's got to ease into it. And hope this video helped you understand a little bit of trig. I will be doing more of these kind of diploma style questions and tackling all that kind of stuff. So I really want to get back into the flow of things if possible. But yeah, nonetheless, thank you guys so much for watching. See you guys later.